Yeah, my name's Sarah Flack, and I do both business planning consulting and grazing and agronomic consulting all over the place. And it's been really a privilege to work on this grass-fed dairy project for about 10 years now. The grass-fed dairy project initially started with, I think it was a small SARE grant back in 2016, when we realized that there were a whole bunch of dairy farms in the Northeast who had stopped feeding any grain to their dairy herds, and they were doing just fine despite lack of technical assistance or official research or anything like that. And so I teamed up with Heather Darby and her really great team at the University of Vermont. And for the first couple of years, we also partnered with Fay Benson in New York State at Cornell. And we started working with those farmers to, at first, really just find out what were their questions and what was going well on the farms. Why were some of them really thriving and some of them struggling a bit with being 100% grass-fed with dairy cows? And so in that first 2 years, we really kind of honed in on asking, hopefully, the right questions. And then Heather and her team applied for some funding. And so the first pool of funding was SARE funding, and then the second funding was through OREI. And so we've been now collecting data for on some things for 10 years and on other things for about 8 years. So what I'm going to do today is I'm going to go through not just the portion of the grass-fed research project that I have been doing, which is the cost of production, working on the financial viability with the farmers, is I'm going to present little snippets and highlights from all of the different researchers participating in the grass-fed project. So there'll be some things I won't be able to answer a ton of questions on, and then there'll be other things where we can definitely go deeper into it. So that's my contact information if you need to reach me and ask follow-up questions. There's also, I have a resource table over in the corner, and that's my mom sitting there, Jean. So there's a whole bunch of the grass-fed dairy resource materials that are over there. It's just a single copy, so please don't steal them. But there's information on where you can get those online. So the research project, the key goals were to identify the management strategies that were really working on those farms to make sure that they were really financially viable. Then understand the grazing management and the young stock management, because it's not just the cows that are not being fed any grain, it's also the young stock. And they're often getting turned out to pasture when they're 3 or 4 months old. So we wanted to understand what's working and what's not working with the young stock rearing. There are some folks who are studying parasitism, animal health and productivity, looking at rumen development in the young stock. Then there's been a whole bunch of research on the high energy forages and soil fertility needed to produce the type of forages it takes to support the dairy cows without the grain. And then there's been a whole really fascinating piece done by Roy, who is doing a workshop, I think later today, on the sensory evaluation of the milk and some of the other dairy products. And if you go to his workshop, he might even have you like tasting the milk and the cheese and things and showing you how he's trained his sensory panel to be able to detect the flavor differences in the different types of milk out there, depending on what the cows are eating, how they're being fed. If they're being fed grain or just pasture. And then the really important part of the whole project has been outreach to the farmers to get the information back out to them. So this is the current team working on the grass-fed project. This is the final year. So 2026 is the last year that we'll be doing this. So we're pulling together the final resource materials and collecting the last of the data this year. And there's a few folks on here where you'll see some of their data, but I didn't have time to pull everything together yet. So it'll just be snippets of some portions of the project. So the ones I do want to talk about today are the nutrient content, the fatty acid composition in the grass-fed milk compared to conventional milk and compared to the organic milk I'm not going to talk about the milk sensory evaluation, but if you want to have fun, go to Roy's workshop. If I have time, I'll talk about the whole farm nutrient mass balance. That's looking at the quantity of nutrient coming onto the farm in purchased feed or fertilizer and the quantity leaving the farm in the milk or cull cows, because that shifts pretty radically once there's not organic grain or conventional grain coming onto the farm, and these grass-fed cows are shipping much less milk off the farm. So it's a really different inflow, outflow from the farm. And I'm not going to talk about the high energy forage research trials. Heather will probably talk about that in the session that I think immediately follows mine in here. And I am going to talk about some of the calf rearing information and the information on internal parasites, which ended up being much more interesting than I thought it was even going to be. And then I'll definitely present some information on cost of production. And feel free to like wave your hand and ask me questions as I go along. I think we've got plenty of time to hopefully get through about 60 slides today. So I first wanted to just define what is grass-fed, because it does not have a national definition the way the word organic does. And so there's lots of places that make grass-fed claims where they might not meet the same definition of grass-fed as another farm. So all of the farms in this study are from dairy cows that are being produced with absolutely no grain in the ration, also none for the young stock. So they're all raised from birth without grain. And so the ration, even though it's called grass-fed, it's obviously not just grass. It's grasses, legumes, and forbs. And then there's obviously also supplemental minerals and water. But it's a much more limited toolbox that farmers have to balance their rations. So it's a very interesting time in terms of milk markets right now in the US. And so I just want to say a little bit about that, because how many people in the room here are farmers? And how many are service providers working with farmers? Okay. So particularly for those of you who are service providers, the demand for grass-fed milk and actually also organic milk currently significantly exceeds the supply. So we've gone into another grass-fed and organic milk shortage. And so the organic and the grass-fed milk buyers are paying higher pay prices and offering higher grass-fed premiums. And so those of us who are service providers are getting contacted by a lot more farms who are thinking about either starting up a new grass-fed farm or are thinking about transitioning from conventional to grass-fed or from organic to grass-fed. So it's just good to have a sense of like what's going on now out there in the milk markets. When we first started this project, we were able to find a couple of hundred grass-fed dairy farms. And the last time we sent out a survey, there were close to 600 grass-fed dairy farms on that mailing list. So it's very rapidly growing. So there are two different grass-fed dairy certification standards. They are not USDA, so these are like separate organizations. And so different certifiers are partnering with either American Grass-Fed, AGA, or with OPT, and are using their grass-fed standards. So it's just important to know that the standards are pretty much the same, but there are two different organizations. And depending on which milk buyer the farm is selling their milk to, they need to choose a certifier and the grass-fed standard that that milk buyer requires. Oh yeah, I also wanted to mention that a lot of these grass-fed milk buyers, in addition to requiring organic certification and the grass-fed certification, also are now starting to require some of the regenerative certification. And that's definitely the Wild West right now in terms of like lots of different certification, different standards. It's a lot more work for the farmers, and it's also an added expense because most of the farmers are then also paying all of these certification fees for multiple inspections. So very unstandardized, kind of like how it used to be back in the 90s in the organic markets. There's also a couple of the grass-fed milk buyers are now requiring all of the cows in their supply chain to be all tested and have A2 genetics. So that's an added cost that the farm takes on in order to be able to get the grass-fed premium. So interesting days. Generally, the grass-fed standard is different than organic in that for organic, you can feed organic grain. Grass-fed, no grain can be fed at all. Organic, during the grazing season, which needs to be at least 120 days long, you need to hit 100, you need to be at least 30% dry matter intake from pasture during that grazing season. It's a day-weighted average. It's a pretty low bar. It's pretty easy to hit 30% in 120 days. To go grass-fed, it's a much more challenging bar. It needs to be at least 60%, and it requires a longer grazing season of 150 days. But you'll see when I start presenting the data, the farmers are far exceeding that level in general. But in a dry year like this year, there were a few farms who got very close to that 60% because the pastures were not regrowing quite as well. So, in case I forget to mention it later, we've got a huge number of resources, and there's copies of this full sheet in the back that you can take a picture of, and then you'll have links to all of the online resources. We have a whole grass-fed dairy webpage on the University of Vermont's Northwest Crops and Soils website, and there's actually an online training course on grass-fed dairy. There's a whole grass-fed production manual. There's also a few copies of those in the back. And we do have a couple of extra paper copies of things. I didn't put them out, but you can either find me or Sarah Ziegler with UVM. If you're a dairy farmer and you really want to know more about this, we can give you some paper copies today. And these are just some of the publications that we've got. We've got one on forage quality. Every year we do a cost of production one. That's the cover of the grass-fed production manual for farmers. And there's a couple of surveys. I can't list them all, there's so many. So what I'm gonna go through first is the most recent survey data from 2024. This one was mailed out to 509 dairy farms, and and it was 351 that we were able to find on the mailing list back in 2019 when we did the previous one. We had a 28% response rate, so 144 farms got back to us, and the geographic spread of those farms was New York, where there's a lot of grass-fed milk buyers, so there's a lot of real big concentration of grass-fed farms in New York. Similarly, in Ohio and Indiana and Pennsylvania, that's really where the largest density of grass-fed farms are. But we also had respondents from Vermont, Wisconsin, Maryland, Virginia, and Minnesota. So the grass-fed farmer demographic is a little different than conventional dairy farmers. Average age is 47, almost 48 years old. The national average is 58, so they're younger. The farms who responded to the survey had been grass-fed for about 7 years and certified grass-fed for about 5. So pretty experienced grass-fed farmers. 75% of them were part of the Plain community. So that doesn't mean they're necessarily old order Amish. That would also include some of the horse and buggy Mennonite, which would be folks who might be using tractors to do their cropping, but they might go to town with horses. And smaller herd size than average, 48 cows on average. And the majority of the grass-fed cows that we see are crossbreds. But I wanted to point out that anytime I have a chance to point out the fact that Holsteins are great for grazing, it's not just Jerseys and crossbreds. 32.6% of the farms have Holsteins, and they're Holsteins that are doing very well without any grain and making quite a lot of milk. So don't be biased against any particular breed of cows. Well, I will say from personal experience, brown Swiss are actually the breed I see have the most difficult time breeding back without any grain. But all of the other dairy breeds seem to do very well being grass-fed with the right management. And 25% Jersey. So one of the things that's really different between a grass-fed and a grain-feeding farm is the acreage needs per cow goes up quite a bit because you've got to replace that grain with forages. And so in the survey, it was 197 acres was the average acreage on a farm, which was just over 4 acres per cow. And that was pasture and fields for producing hay or other stored forages. But 72% of those farms were also buying in 35% of their additional forage needs. So that 4.1 acres is not feeding the whole herd for the year. That was producing a portion of the feed, and then they were buying in another 35% of their forage needs. In addition, to take some of the pressure off that land base, 32% of them were also doing some custom grazing off the farm. And then 51% were growing some annual forages. And so that might have been midsummer annuals, or it could have been triticale overwintered and grazed in the spring, or a fall cool season cover crop to graze, or they could have been harvested. They were also producing some of their own bedding for bedded packs, or bedding in pens. On average, a little over 10 acres was being harvested for bedding. And then 77.2% of them were testing their soil, and 81% of them were buying some fertility. But you can see there's a few folks in there not testing the soil, and there's a few folks not buying fertility. And then there's also a few folks who were buying fertility but not testing their soils. So this is where we can start to dig in to be like, well, how can we help as technical assistance providers? 30% of them also said they felt like their current forage quality and yield was limiting their milk production and therefore their income. Farmers who said they were following the soil test recommendations, and those who are also purchasing soil amendments, they self-reported that they were making a lot more milk than those who are not. So some basic agronomy there. And in addition, it was the farmers who were not just buying in poultry manure, were buying in different mixes of fertility. Those were the ones who had the highest milk production. So for organic, it's really hard to get a nitrogen source that's approved and affordable. So like poultry manure is typically what people buy in, it's what's available. But that isn't necessarily addressing some of the other nutrient needs, particularly trace minerals and things like that. So their grazing season averaged 195 days, and almost 80% of them were giving them a fresh paddock at least twice a day. So after each milking, some of them were giving them paddocks more frequently than that. And about half of them said that during the grazing season, they were getting somewhere between 80 and 100% of their dry matter intake from pasture. And so again, just reminding us that additional supplemental feed in the barn is all going to be baleage or haylage or dry hay or something like that. So this is interesting. Farms that had more acres per cow and farms that were feeding a larger amount of pasture during the summer. So they were saying they were maybe, 90% or 100% dry matter intake from pasture instead of 70 or 80%, reported that they had cows that produced less milk. So higher pasture intake, cows producing less milk. And this will be a theme that'll come up in a couple of the pieces of data that we'll look at through the day. So there's a big difference between milk production and milk sales on grass-fed farms because the amount of milk that they have to feed to the calves is really large. But their self-reported milk production before calf milk is taken out was 10,599 pounds. And so I work with lots of grass-fed farms, so I look at that number and I'm like, yay, that's really good. But if you're coming from a conventional dairy background and you look at that number, you might be like, wow, that is really low. How are they possibly cash flowing that farm? So it's just all a matter of context and perspective. Averaging 4.4% fat, 3.4% protein. We were interested in how many of them were fully seasonal, maybe drying the cows off for a couple months. And how many of them might be on an alternative milking schedule, like milking once a day or milking 3 times every 2 days is some of the alternative schedules that we see. And what we saw is that 88.9% of them were just regular year-round milking, and 87.5% of them were milking twice a day. So there's still a little group of them in there that are seasonal and have alternative milking schedules. And we did a little side tangent research project that I don't have the data on here, that where Sarah Ziegler pulled together some of the information on farms that are fully seasonal or have alternate milking schedules, because we were really curious to see if the improved labor efficiency or feed efficiency in those systems might change cost of production. And there's one copy of that report up in the back if you're interested in looking at some of those alternative milking frequency information. So the calves, they start grazing them at about 3.8 months of age. So those calves are probably still on milk when they go out to pasture. And they're being fed on average 1.75 gallons of milk a day for 5.1 months. So that's quite a lot longer than the industry standard. And if a farm is getting, $50 to $58 a hundredweight for their grass-fed milk, and they're feeding that much milk for 5 or 6 months, some of them for longer, that's a pretty significant opportunity cost. So it comes out to 272 gallons per calf. So that's everything I was going to present on the survey. There's actually a copy of that 2024 survey up in the back there, and you can get it online. I just pulled out some of the fun snippets in there. Are there any questions before I shift into talking about the cost of production data? Jen. Yeah, so the question is, did the farms that reported lower milk production, was that correlated with higher pasture intake during the grazing season? Yes. And higher acreage per cow, per mature cow? Yes. So both of those were correlated with lower milk production. Yeah. Interesting, right?
Thank you. And now I don't have to yell next time. And you don't have to restate next time.
Okay. All right. Is that it for questions? Okay, so now I'm going to shift gears and I'm going to talk about the cost of production data. And this is the one portion of the project that I actually do myself. The survey is done by other people. Everything else is done by other awesome researchers. So the cost of production data is a smaller data set. The farms, most years, they're primarily in Vermont and New York because they're within easy driving distance of me since I live in northern Vermont. And we've been collecting the cost of production data since 2018. So we have a very robust benchmark on management practices and cost of production for since 2018 now. But what I'm going to present is information mostly from the 2024, the most recent kind of full data set that we have. I'm in process right now of collecting the 2025 cost of production. And it is fascinatingly different than 2024, but we can talk about that after if you want to. So the herd sizes in this cost of production data set, which is 32 farms in 2024, is a little bit bigger. It's 65 cows on average instead of 48, with a really big range from small herds of 28 to over 150 cows in the data set. More acreage per mature cow than in the national survey. So 5.17 acres per mature cow. But again, not producing all of the forage needs for the herd on that acreage. Farms were estimating that they were purchasing an additional 30.3% of the forage needs. So you can see one of the themes coming out here is it takes a lot of land. Once you're not externalizing the feed costs off to some Midwest grain farmer that's trucking it in and you really have to do it all yourself. It's a lot of land. So some of the other demographics of the farm, 59% of them also had some other income sources and 22% of the farms had some additional farm like enterprises that were generating them some income. This was a more experienced group of farmers, 11.7 years organic and 6.6 years grass-fed. So a lot of these were farms that started out organic and then at some point converted to grass-fed because they felt the grass-fed premium was worth it, or in some cases, they were philosophically attracted to the idea of not having to have the grain truck come all the time. Average grazing season of 185 and a half days at 82% pasture intake. And this group of 32 farms is a little bit further north than the national average that included some Ohio and Indiana and some of the other farms down there. So milk production and milk sales. The farms were selling 548,000 pounds of milk. And so that's milk sales of 8,410 pounds sold per cow per year on average. That does not include all of the milk the calves were drinking, and we'll talk about that in a little while. But the range is really interesting. So there were some farms selling as little as 4,500 pounds of milk per cow, and there were other farms selling over 12,000 pounds of milk per cow. So really big differences in their management decisions and management systems on these farms. So the farmers who participate in the cost of production project with me every year, I visit, sometimes I'll do it over the phone, and then they get a report back immediately that says, you know, here are all of your costs per hundredweight, and then here's the benchmark. And the benchmark we break down, I shouldn't say we, it's Sarah Ziegler at UVM. She does most of the hard work with the data. I just do the fun stuff of collecting it and visiting the farmers. So we break it down into the average, and then we have the lowest cost of production group, the medium cost of production group, and the highest cost of production group. So the farmers can kind of look at where they're falling in that. That does mean that potentially we're skewing our data over time, because the farmers that I visit to do the cost of production data collection with every year, they are able to use this as a technical assistance visit and improve their management to lower their cost of production as they look at this information. But we do have new farmers joining the project every winter, so hopefully we're not skewing the data too much. And the cost of production still looks plenty high. So you can see here the, I don't know if I can use this pointer here, but the herd size is a little larger in our lowest cost of production group. Goes from the average herd size of 65. You can see 79 cows is the average in that low cost of production group. And I'm not going to like present all of the data because that would take me hours. It's really fun, but I'm just going to kind of give you some snippets. And then tomorrow morning, I'm going to go into more detail on the management stuff associated with some of this cost of production data. Okay, so milk per cow. So we said on average, they were selling 8,410 pounds of milk per cow per lactation. But you can see in the low cost of production group, they're selling significantly more milk per cow. Almost 9,800 pounds per cow is being sold. And then when we look at the highest cost of production group that would have the smallest net income, they're shipping 6,700 to 6,800 pounds of milk per cow. And farmers were really excited about this cost of production data. So at the beginning, they really wanted to know, like, how many pounds of fat am I making per cow and per acre? And then over time, as we started to figure out like what actually correlates with the farmer having better financial viability, we kind of shrunk down what we're reporting back to them and some of the information that we're collecting. But we still were reporting the fat per cow and fat per acre, because folks were interested in that. So looking at the calf milk again, in 2024, farms in this project were feeding actually more milk for longer than the survey farmers. So they were feeding 1.86 gallons of per day for 5.25 months. So when we added that milk back to what they were selling, they were actually producing just over 9,200 pounds of milk. So it's a big opportunity cost. one of the things that has really changed in all of the dairy markets, but particularly in grass-fed, is at the beginning of the project, if you raised up a heifer, you would only get like $800 or $1,200 for it. Now, if you raise up a grass-fed A2 certified organic certified grass-fed heifer, you might be able to sell it for like $2,500 to $4,500. There are grass-fed certified cows selling right now for like $6,000. And so the beginning of the project, the farmers were like, oh, I got to raise less calves and sell more milk. And now they're saying, I got to do the math on that. Maybe it's starting to be worth raising some extra calves to sell. Yeah, question in the back. The question is, are they all replacements? Initially, yes, farmers were primarily just raising replacements because they were so expensive to raise. Some farms are now crossing with a beef bull for some of the cows where they don't want to keep replacements, and they are raising up, black hided calves. Some of them are selling them at like 10 days when they're nicely started and getting a significant amount of income. Yes, I mean, some of the farms in 2025, I'm starting to see some of the beef and calf sale checks coming in for the year are almost as big as the milk check for some of these grass-fed farms. So we're really going to have to look at how we analyze the data this winter to make sure we're looking at a true cost of production, even if beef prices start to go down. Yeah, question over there.
Do you have data on how large the calves are, or at what age they're leaving the farm?
I've got a little bit of that I'll show. It's not my part of the project, but there is some information on that, yes. And UNH right now is doing a really cool project. I'll show you some of where they're actually like weighing the calves all the time and looking at different amounts of time feeding the milk to hone in on that a bit. Yeah.
And did that hone in on grass-fed production?
Yes, it's just grass-fed. Yeah, because when it comes to calf rearing, we could find no other studies that were doing research on calves where they weren't actually feeding the grain. And it really is different. And we got quite a bit of pushback at the beginning when we said, oh yeah, we need to feed them 2 gallons of milk for 6 months. And everybody said, whoa, no, nobody does that. But that's what all farmers do. So we really do need some good data on it. So labor efficiency. Labor efficiency is another thing that really correlates with a lower cost of production. You can see here, these farms, most of them are managed by 2 or 3 full-time equivalents. That includes paid and unpaid labor, and we say 3,000 hours is a full-time equivalent. So some of these farms that are, 2.5 full-time equivalents, that might just be 2 family members there on the farm. But it's 30 cows per FTE on average. But again, the lower cost of production group, they are milking more cows per FTE and they're selling more milk per FTE. One of the other things, the bottom point on this slide is that the low cost of production farms were also generating over $10,000 in additional income, non-milk income per FTE. So that might have been additional beef sales or heifer sales or crop sales. So here's some of the statistics. Farmers that were managing more cows per FTE had a lower total cost of production with each additional cow managed that was 56 cents per hundredweight equivalent lower for each additional cow. And farms that were selling more milk per cow and more milk per FTE had a lower cost of production and higher net income. Seems pretty obvious, but it's always nice when the statistics line up with what you're going to see. They didn't always. Farms that spent more per acre on purchased seed and fertilizer produced more milk per cow. So those inputs were paying off in forage quality and milk production. And then we also saw in the cost of production data, I asked them what they think the feed quality is every year of what they bought and what they made. And the ones who said that what they made or purchased was excellent were on average producing 1,432 pounds more milk per cow. So forage quality turning right into net income. So this is very similar to what we saw in the survey, which is a higher proportion of pasture in the diet during the grazing season was associated with lower milk production. We can talk about that for hours. I'm just going to skip over it. But then check this out. We found that in 2022, 2023 and in 2024, farms that had a longer grazing season had a lower cost of production by 18 cents per hundredweight equivalent per day that they made their grazing season go longer. And when I'm wearing my business planning consultant hat, this is what I'm always saying to my farmers is, for every day or week or month that we can add to your grazing season, that reduces your stored feed costs and your bedding costs. You don't have to go into those winter costs yet. And so it's interesting that it's very clearly lined up with this for the grass-fed farms, but not so clearly lined up with the amount of pasture that they're getting during the grazing season. That's everything I'm going to do on cost of production today. And now I'm going to talk about the milk fatty acid profiles. But yeah, question. Yes, we did that. If it wasn't wonderfully significant, it's not in these slides, but in the very back of the room is the full 2024 cost of production report. And that has the individual numbers in there. And I just put one copy on my table over in the corner, but on the UVM table, they probably have a couple extra copies of the 2024 report. I've also got a few in my bag I could hand you if you really want to dig into it, because there's a lot more detail in there. Yeah. Yes. Were any of these herds using robots to milk the cows? Awesome question. No. I keep waiting to see if somebody can hit 60% dry matter intake consistently with a robot on pasture. I got a call from a farmer in in Washington, who says he's at 70% intake from pasture with a robot, but I'm going to have to fly out there and see it with my own eyes, because I've worked with a lot of farms with robots, and the highest pasture intake I've seen during the grazing season is 54%. So have you seen anything higher, Cheryl? No. Yeah, question in the back. No, it's not broken down by month within the cost of production group. No. Heat stress is on the long list of things I suspect might be contributing to that. But there's a long list of things that I think it could be. And I do think it's an opportunity for improvement. And I don't think I have that slide in here, but I'll put that slide in tomorrow mornings. Yeah. So, yeah. Yes, you can transition cows to grass-fed. So they have to be certified organic. And then you can either transition cows that are already certified organic to grass-fed. It's not a full 12 months. I can't remember if it's like 2 months or 3 months where they have to be no grain and you have to have the other approved inputs that you're allowed to use. But yes, you can transition to grass-fed. Yep. All right, should we talk about milk fat? Megan.
Is anybody looking at
Is anybody using or looking at agroforestry and grass-fed? Not specifically, but lots and lots of the farms have tree plantings, and they are using some shade pastures that have trees on hot days. I see really beneficial use of tree plantings along lanes to improve heat stress going back and forth to the pastures. But no official research or anything is being done. Okay, so this next section is research being done at UVM by Jana Kraft and her graduate student, Emily Youngmark. And so I'm just going to go through some of the data that they have on the differences between the grass-fed and the organic and the conventional milk. So milk is 87% water, 5% lactose, the sugar portion, 3.2% protein, though we know it varies, and 3 to 5% fat. The milk fat is 98% fatty acids, and it is the most complex fat source. There's over 400 fatty acids in milk fat. If you compare that to like olive oil or peanut oil, that's 11 or 12 fatty acids. So it's a really different fat. And it changes significantly based on the breed of the animal, what they're eating, the rumen community, so the microorganisms in the rumen, and then the animal's health and how its metabolic function is. So the first piece I'm going to talk about is the difference between the amount of omega-6 fatty acids and the omega-3 fatty acids. They're both essential. The omega-3 fatty acids are the ones that are really strongly associated with a decrease in risk of heart disease and inflammatory diseases such as arthritis, and they can improve gut health. The typical standard American diet has a lot of omega-6 and a lot less omega-3s. So you see these ratios of like 15:1 and 20:1. Ideally, you'd like to have the ratios be more like 1:1 or maybe 4:1 at the highest. The forage-based diets tend to increase the omega-3 in the milk fats, and the corn-based or the grain-based diets increase the omega-6s. One of the other things I didn't realize until I started talking to Jana is that the higher omega-3s can also be healthier for the livestock themselves. So here's the conventional milk at the top is the yellow line. You see you've got a 7:1 ratio, so it's still outside the healthy range. Then you've got organic is the blue line at 2:1, which is pretty healthy. And then the grass-fed is 1:1 underneath there. I'm going to go through these really fast. Now we'll look at CLAs. Conjugated linoleic acid, another one that decreases heart risk and inflammatory issues and can improve gut health, also is increased in the animals consuming a high forage diet instead of the grains. And we see a very similar trend, except she flipped the graph just to confuse us. But the yellow line down at the bottom, 0.31, that's the conventional milk. The organic milk is 0.78, and then the grass-fed milk is the highest at 0.91. And then the third group of fatty acids that she's looking at are the branch chain fatty acids. These are only found in rumen products. You can't get them in other foods. They improve gut health and are associated with anti-carcinogenic properties and anti-diabetic properties. Again, they're higher in these high forage diets. And she saw a similar trend with these, with the grass-fed at 2.4%, the green line at the top. Organic is still very respectable at 2.2%, and then the conventional milk at 1.7%. That was a high-speed overview through something that took Jana like 2 hours to explain to me. If you have really complicated questions, I will not be able to answer them. But she and her graduate student are really just, this is what they're doing in their lab, and it's very interesting for a lot of different projects, but including the grass-fed project.
Sarah, I do have one question.
Yeah.
It's a simple one, I hope. The fatty acid research is that looking at the CLA fats in aggregate, or is she also breaking them out into individual fatty acids?
She is breaking them out into all sorts of detail, and I didn't bring that graph because it melts my brain. But yeah, it's really fascinating where she's got this giant pages where it breaks down every single subtype of each one of those fats and looks at them and the differences from the different management systems. Yeah, it's really fun. Any other questions on that I probably can't answer? Okay, so the next part, I'm going to go through some of Bryony Sand's research. She was at UVM. She's just moved to Scotland, but she did some really great research when she was here. So she was looking at some of the calf health and internal parasite information. And so for those of you who have listened to your grazing consultant, or maybe you're a grazing consultant who is always telling you you need to don't graze your pastures down really short, just be thinking about that the whole time you're looking at this parasite data. So she actually looked at internal parasites in the cows as well as the young stock, and she saw that cows grazing pastures down to shorter heights, which is what your grazing consultant always tells you not to, had picked up more parasites, and they had significantly more worm eggs in their feces. So they were carrying more parasites and shedding more parasites onto the pasture. This actually really made me pause. It says cows with more worm eggs in their feces produced less milk. Because we generally say, oh, you don't have to worry about the mature cows. They have an immune system. They'll be okay. It's the calves we have to worry about on these organic farms. But when we think about the fact that higher milk production and higher milk sales per cow is correlated with a lower cost of production and higher net income, I think we really need to be starting to pay attention to whether our grazing system is infecting the cows with parasites, lowering milk production, and therefore lowering the farm financial viability too. Yeah.
Do you think that is related to the decrease in efficiency that the animal produces because it's dealing with?
Why is the cow making less milk with the parasites? Yeah, I'm sure it's a combination of like damage to the gut lining, sharing its calories with some parasites, and just like decreased digestive function. Yeah, Bryony would be able to answer that question really well though. Cows in earlier stage of lactation had more worm eggs, which makes sense. They're less, they have a less robust immune system in early lactation. They also had a lower butter fat content and a higher somatic cell count. So these farms would be getting paid less butter fat premium and also not getting as much of a milk quality premium. Shifting to looking at the young stock, the more days that the calves were left in the pasture, the more parasites that they had, except when they were left in the pasture for a really long time, which for this study was 30 days. I thought that was interesting. And I'm guessing that those larger pastures would have been just like larger, left in there longer. There hopefully would have been less opportunity for the calves to graze the pastures down really short and infect themselves in the bottom couple of inches. But in general, it's the same information for the young stock. Young stock grazing the pasture for just one day also had lower coccidia. And so it's not just the worms, it's also the coccidia. Coccidia is more of a problem for an organic farm than the worms because there are a few approved synthetic dewormers that you can use under certain circumstances if you're a certified organic dairy. But the Corid and the Decox are not approved for use on an organic farm. So this is really one that farmers need to avoid. And now tying back to this question of, do we really have to feed all this very expensive milk to these calves? The answer is yes. Animals that were fed milk for longer had fewer worm eggs in their feces. We also saw that animals that were raised in group feeders instead of individuals tended to have more coccidia. And that is, the group feeding is a requirement now, an animal welfare requirement for most of the farms to follow. That's everything on parasites. Now I'm going to present a little bit of information on the calf rearing study. So if it's a specific calf project, this might answer that question, but.
It's actually, we had a comment from online that Bryony shared in a webinar yesterday that the over 30-day scenario, they were feeding hay because of drought.
Aha.
As a piece of context, right? It's all context.
That is really helpful information. Yeah. That could make it, yeah, because then there would be less time spent grubbing down short pastures and infecting themselves. Great. Yeah, Bryony's been doing a whole series of webinars for people and they're recorded, and she's a great speaker and on a wide array of topics, from everything from the parasites and young stock rearing to dung beetles. So this is the ongoing portion of the study that's still happening at UNH, where they are raising a bunch of calves right now and on different durations of milk and hay quality to see how they do, looking at rumen development, growth rates and things like that. So it's just very preliminary data. I think they're going to be doing some of the final measurements the end of this month and February. So they are breaking the animals into 4 different groups, feeding milk for 90 days and 180 days, and supplementing them with either a really high quality, highly digestible forage or a poorer quality forage. And it wasn't a huge difference in forage quality. Like both of them were pretty decent, but one of them was not quite as good as the other. So there's these 4 different groups, 45 calves that were enrolled through last year into this month. And they're measuring everything: blood tests, weights, temperatures, growth rates. They start supplementing them with hay on day 6. They started them all correctly on the right amount of colostrum given right off. And they also have a mineral supplement since they're not getting supplemental minerals in a grain mix. And what they saw is that the groups that were fed milk for 6 months had a significantly higher rate of gain overall. Whether they were fed really good quality hay or poor hay, both of those groups fed milk for 6 months did much better. And the total weight at 6 months was also significantly higher. And I'm very curious to know if there's a significant difference between the poor hay and the good hay group, because it looks pretty similar in terms of the end weights. So that project is being done by Andre Brito and his grad student here in New Hampshire at UNH. I probably can't answer a ton of questions about it, but if it's something simple, I might be able to. I think they might be largely Jerseys, but they might have brought in a few calves from a few other places. Is somebody here from UNH who might know? Yeah. Okay, so there's Jerseys and Jersey crossbred with Angus, a little of both. Okay, great. Okay, and so they're being randomly distributed between the groups so that the Angus Jersey crosses aren't just in one group and not in another. Yeah, because I do remember talking to them about the fact that like it's not that big of a herd there, and they needed to have a big group of calves all at once to go through the study group. Yeah. Oh. Anything else on that I can't answer? Yeah, in the back. Oh, yeah. It was 90 days and 180 days, basically 3 months and 6 months were the 2 different durations. And we did discuss feeding different amounts of milk, but it seems like farmers are fairly consistent in the amount of milk that they're feeding. The variation is more in the duration of milk. And so for at least to start with, that's what we decided to focus in on. Yeah. All right. So this next section of the project is the whole farm nutrient mass balancing. And this was done with a much smaller group of farms. I think there was only about 10 or 12 farms in this group. This is something that Sarah Ziegler had lead on. And this was because we were all asking these questions about like what happens on a farm that shuts off the grain spigot and you no longer have 200 tons of grain being imported onto your farm every year, passed through the cows and going into the manure and getting spread out on the fields. And that is often being combined at the same time where the farm needs more forage, so they might be expanding their land base. And it turns out that when cows make less milk and maybe are eating less overall dry matter, they're also making less manure per day. So we've got like less manure and less nutrients coming onto the farm in grain, but we still have a lot of nutrients leaving the farm in milk, though it turns out that milk production is decreased, so significantly that it is less nutrients than we thought it would be leaving the farm. But then you've also got nutrients leaving the farm in the cull cows and the calves that are sold. So, so they used the Cornell University Whole Farm Nutrient Mass Balance, and you can go online and look at the system that they use there. So it's never been done with a group of grass-fed farms before. So it was kind of a little experiment to see, what does it look like for the grass-fed farm. I was a little surprised to see that that there were more farms that looked a little more balanced than I thought that they would. And farms that were pretty balanced tended to be making their own forages, but they were buying in some fertility amendments, and they were selling a lot of milk. And we also had some farms that were probably depleting their soil nutrients. And because one of the things this model does not factor in is other losses. So nitrogen volatilization, losing the potassium when it's leaching out of the soil, those sorts of things aren't factored into this model. And I also want to say this doesn't also account for any sort of financial stuff. It really just looks at nutrients coming into the farm and nutrients going out of the farm. So great. That leaves us a good, I think we have 15 minutes for questions because this session actually goes for until 10:30. I put in a few summary slides just to try to tie things together at the end, and then we can just shift into questions. But I will say that, particularly in New York State right now, there are so many grass-fed milk buyers offering a wide array of premiums, but also in Vermont. Less so when you get over into New Hampshire and Maine, but a lot more kind of New York, Pennsylvania, and Ohio, in that area. They really just the milk buyers really need more milk. They're really trying to figure out how can we get more farms to go grass-fed. The organic milk price has gone up. The grass-fed premiums have gone up. Many of these grass-fed and organic buyers either don't charge any stop and hauling charges, or they're much lower stop and hauling charges. So there's a lot of incentive right now, since conventional farms are paying a lot in stop and hauling charges to have their milk picked up, and the milk prices are going down. So I anticipate we'll see a lot of farms looking at these models. But as farmers and as technical service providers working with farmers, it's really important that dairy farms who are thinking about this really understand what is their current cost of production and how is that cost of production going to change if they go grass-fed and their cows are making significantly less milk. The grain bill goes away, but where is that additional forage going to come from? Is the digestibility of that forage good enough, and the energy content of that forage good enough to support a financially viable level of milk production for the farm? And that's really like a math problem that each farm has to do themselves. Like they need to do a cash flow projection either themselves or with somebody who can help them figure out, is that different pay price better? For some farms, it might be better to go from conventional to organic. For some, it might be to go conventional to grass-fed. And for some of the grass-fed farms, it might be more profitable to go from grass-fed back to feeding grain and being organic. Like it's very farm specific for them to understand what the best model is for the land base and the resource base, and their personal interests to do. So yeah, these are just my summary slides. It's a really different model, much lower milk production, a lot of milk fed to calves. Cost of production is significantly higher because there's less hundredweights to divide those costs over. Calves are doing better with lower parasites and a higher rate of gain when they're fed that larger amount of milk for 180 days, according to the study. The cows are producing more milk when they're fed the higher quality forages, and the farms that are buying in seed and fertility. Cows are producing more milk when they have the lower parasite loads, and the cows with taller post-grazing residuals had lower parasite loads. And then for the cost of production was lower on farms with improved labor efficiency and lower on farms with a longer grazing season. And then the milk fats were higher in omega-3 branch chain fatty acids and CLA in the grass-fed milk. And I'm not going to talk about any of the stuff that Roy is going to talk about in his sensory evaluation session, but what he has found in general is there does seem to be a very wide range of different flavors and aromas, and I think also mouthfeel in the grass-fed milk, which makes sense. They're being fed, much more diverse diets with forbs and grasses and legumes, and also different types of either dry hay or fermented feeds. So that leaves us more time for question and discussion.
And since we have more formal questions, I'm happy to bring a mic to whomever would like to ask a question, then we can get them all captured. And unfortunately, we have one, so you get to wait for me to run around between people. Okay.
I have two questions. One is if any of the research includes calves that are raised on nurse moms versus just feeding like buckets or, individual calf pens.
Yes. So I don't think I put any of that in either today or tomorrow's slides. I might be able to dig it out by tomorrow. Yeah, so there are a number of farms that are raising calves on nurse cows. And there are also some farms, a decreasing number of farms, because these were the farms who really shipped the smallest amount of milk and had to make some changes so that their net income was higher. There were some farms also doing what was called the madre method, where they leave the calves on the mothers and let them nurse. And, by the time you get in a couple of months, the calves are pretty savvy and they get up in the morning when the cows come in to get milked and they quickly drink all the milk. And they also started to figure out how to drink from cows that weren't just their mothers. There's still a few farms that do that for a portion of the calves' life, and then they shift them to a different system. There's definitely a number of farms who are still doing nurse cows. There's a handful of farms who have stuck with nurse cows long-term and really like it. Several of them will either have a totally separate pasture system where the calves run with the nurse cows for the whole grazing season. They've got a separate, hoop barn bedded pack or compost pack for them to be in the winter. There's other farms who have found they like to run the nurse cows with the milk herd. And then as they come in to be milked twice a day, they just open a little gate and scoot the nurse cows into a large pen with the calves. So they just get nursed on by the calves twice a day. And then their udders have a little more time to kind of recover, refill, not get as chapped from having calves on them all day. But then there's, I would say more than half of the farms are raising them in group pens on various types of feeder buckets and things like that. Yeah.
And then if I can ask a second question, does any of the research include, a lot of this was the dairy was being bought by a buyer versus like a direct to consumer. So was any of the research more on a direct to consumer basis or mostly on the buyer bought milk?
Yes. So all of the farms in the cost of production portion of the project are shipping milk to one of the milk buyers. But I have been doing cost of production analysis using the same system with a handful of farms who process their own milk on farm. And it's been fascinating. I'd love to do a whole separate project on just that. What I saw is that the cost of production with the farms that were doing the on-farm processing, the cost of production was so much higher that we decided not to include that data in our grass-fed cost of production benchmark. But it's been really fun to work with those farms because I've been able to help them lower their cost of production really hugely. But we do tend to find that the farms who are processing their milk on farm tend to have a higher cost of production. And that doesn't include like the dairy or the creamery cost or anything. That was what was so fascinating to me about it. It was just the cost to like milk the cows and feed the cows and run the dairy farm was higher on those farms. So it's just another area where I'm like, ooh, I want to go explore that next. But the funding runs out this year, so I'll go do something else.
Got a question from the audience?
Question in terms of the calves with a short duration period. Do you know how short the pasture was grazed with those that have a short duration on their mother versus a longer duration on their mother? In other words, is the pasture or parasite load correlated to the height of the pasture more so than it is the calf duration time?
Yeah, so that would be the Bryony research. The way I saw the data is it was two separate sets of questions. And so I don't know if that was on the same farm or not. And as far as I know, that was also separate from the UNH study. So, but yeah, I'd have to dig into that to figure that out a little bit. It's a good question. Yeah.
Is there a data difference between grazing with just a single herd or like just cows, or is there a difference when you're splitting up your grazing with sheep and cattle, using it to break up parasite loads? Is there more data on that?
So that's a really good question. None of the farms that I have worked with in the project were doing much in the way of multi-species grazing, other than the fact that like 60% of the farms I work with, or maybe a little more, are plain community. So there's a lot of horses and mules. But for the most part, they were not grazing the horses and mules in the dairy pastures because they graze things down too short and damage the plants. Most of them would run the non-ruminants in a separate area. But it's an interesting question about, we've always thought as grazing consultants, we've always thought about multi-species grazing in terms of like, how can we make things better for our small ruminants? Because we're always worrying about parasites, in the dairy calves, but not so much in the dairy cows. And we're worrying about our sheep and our goats getting really wormy in our climate. So we think about using beef cows or dairy cows to graze and break up that parasite life cycle for those small ruminants. This is like a fun paradigm shift for me to be thinking like, oh yeah, actually, we need to be thinking about this for these organic cows also. Personally, I think with cows, because of their grazing habit, the fact that they are grazing, using their tongue to like wrap around a chunk of forage, pull it into their mouth and break it off between their teeth and their gums, instead of the sheep and the goats that have the little muscular lips where they can really graze things down very short. I think that we could get tremendous improvement just by having a shorter, a taller pre-grazing height and a taller post-grazing residual without adding in the complexity of trying to also graze some small ruminants. But if it's a farm where maybe there's somebody else on the farm that is interested in running a separate small ruminant enterprise for fleece or meat, I do think that would be an interesting thing to do. There's one parasite, I think homuncus is the one that can still pass back and forth between the small ruminants and the cows. But my understanding is that the rest of them are separate. But I have never heard of using small ruminants to improve parasite pressure on cows. So thank you for asking that question. Now I'm going to be thinking about that for months.
Is there any research on grazing warm season grasses versus cool season grasses, like on the cost of production and also maybe on parasites? Like I guess I'm wondering if warm season grasses, because they're taller, would maybe have less issues with parasites?
Yeah, great question, Erin. So warm season grasses, because they would be grown as an annual crop in our climate, would actually have lower parasite loads for two reasons. One would be you'd be doing some sort of tillage. And so you'd be potentially breaking up and allowing more of the infective parasite cysts and eggs to be killed. And then, yes, most of those warm season annual crops would have a bigger stem. And so it would have like less of that stuff right by the ground would be grazed. More of that would be trampled. Yeah, I think that is an interesting thing. I know that some people with small ruminants have done some of that with annual crops. The thing is that the annual, like if you're grazing millet and sorghum Sudan grass, it's probably always going to be just a percentage of their summer grazing season intake. And the rest of it will be probably from either cool season perennials where they might be getting parasites, or maybe from cool season perennial stored forages, which wouldn't have the parasite risk so much. But in terms of cost of production, we were collecting data for a little while with our small cost of production group on how much they were growing annual crops. And we didn't find any statistical significance within that group, but it's a pretty small group. We've only got 32 farms in our cost of production group. And so we may just not have had enough farms growing enough annuals to really be able to see if it was making a big difference. I will say in that overall national survey, I was really surprised at, how many farms were also growing some annual crops for grazing and for harvest, which makes sense as you go further south, you get more of that midsummer slump when the cool season perennials don't grow as well. And so that midsummer slump, the further you go south, the more benefit you get from growing warm season annuals midsummer. But even up here, some of the farms were certainly planting triticale in the fall and grazing that a couple times in the spring to get a 2-week jump on the grazing season, and also grazing and harvesting some of the midsummer annuals. But we didn't collect cost of production data on that. Yeah.
So Sarah, I have an online question. Has the study captured any data on the typical or average recovery and rest periods between grazing events and how that is correlated with profitability?
Yes. I put so many questions into like the farm management question about grazing, because I was like, we've got to be able to see some correlations here. And so, yeah, we asked them how long their spring, their summer, and their fall recovery periods were. We asked them what was their pre-grazing height, what was their post-grazing residual, percent intake from pasture during the grazing season, the length of the grazing season, and a bunch of other stuff. The only stuff that was statistically significant is what I put in the presentation. So it was just the longer grazing season, like every day your grazing season is longer, you make 18 cents more per hundredweight. Like that was the big takeaway. And I don't think we found anything statistically significant with the recovery periods. And I also don't think we did with the pre and post grazing residuals, but it is a little tricky collecting that data from the farmers because it varies so much between different times of the year, especially if they're doing really good management. Like they're really going to have a wide range in recovery period lengths and a wide range in pre-grazing heights and post-grazing residuals. So we didn't find anything significant there yet. I'm collecting the 2025 data. We'll see what happens next. We've got a really good team at the University of Vermont, Cheng Bin and his grad student Avery. They've been running a lot of statistics for us. So as we dig more into the multi-years of data, then we might find some other interesting information to come out of there. Yeah.
Yeah, I was wondering if there was any cow health data, like along with the grass-fed dairy, like you have the production numbers, but were any of the farms, do they have like collars that are tracking like rumen activity, resting time periods, SCC, those kinds of things? Because I guess my kind of bigger question is the grass-fed demand strictly a consumer-based focused thing that people want grass-fed milk, or is it actually potentially better for the long-term health of the milk cows?
Yeah, that's a great question. So we did collect somatic cell count, and for a period of time, not in the current project, but kind of the previous version of the project, we were collecting Dairy One or DHIA data from a big group of farms. So we do have a bunch of data from that, where we were looking at things like MUNS, milk urea nitrogen, and how that might be correlating with other things. We've got loads of information on cull rates, mortality, things like that. I don't have, the fact that I don't have statistics on that makes me think things may not have been statistically significant. But I will say that A lot of the farms who originally went grass-fed did it before there was very much of a premium. It was not necessarily a financially sensible choice. It was a philosophical choice or a quality of life choice. And a lot of those farms do feel like their cows live much longer. They have, is a lot less production pressure on them, particularly for farms where they might even go to milking once a day. And so, a lot of the farms that I work with have lots of teenage cows. And so they have like pretty small number of calves that they actually have to raise for replacement because their cull rates are relatively low. It's a little different, like for a new grass-fed farm that's just starting up, like that's going to be really different because they're still working on getting the group of animals that's really going to fit the program well. But for those farms that have been grass-fed for a long time, it really does seem like they have very low vet bills. They have, they're reporting relatively small number of health issues and pretty, have a lot of older cows that are doing well. Yeah. That's anecdotal though. Don't have the data.
So we're at time, but we do have one last question that's online. Do you have an idea of how the initial levels of soil fertility impact the likelihood of the positive negative nutrient balance?
Yeah, I was actually talking with Sarah Ziegler about that a couple of days ago. So that is not factored into the whole farm nutrient mass balance and is actually something that's really important because some of these farms are very depleted of nutrients when the grass-fed farm starts up because maybe they were conventional and just not getting paid enough. So part of the deferred maintenance on the farm might have been they weren't buying in fertility, or maybe they're taking over a rundown farm. A lot of the farms, have been empty for a while, or maybe they were running beef, might have been, just continuously grazed. Some of them are converting like fields that were just corn and then left fallow. And so quite a few of the farms really need to have a positive import balance for a period of time to kind of bring things back into balance again so that they're not having to make hay on 10 acres and could instead do it on 5 acres. And that is part of what I suspect might be going on with some of these like very high acreage per cow numbers that we see is like that might start to come down as farms start to improve the fertility and build up some of the depletion that they may have had before they took over the farm. Yeah.